Good evening, grade 9s. I hope that the sound comes out okay. I'm recording straight onto the iPad for this one. I'm going to go through the questions that at least one person had and just skip through to the questions that you want help with. So I'm starting off with question 1. And all we have to do here is distribute. So we're saying minus 2x times 2x squared. And so minus 2 times 2 is minus 4. And x times x squared is x cubed, because we're adding exponents and x is x to the power of 1. And then we can do the same for minus 2x times positive 3x. And we've got minus 2 times plus 3 at least is minus 6. And x times x, again, this is x to the power of 1. So x times x is x squared. And finally, minus 2x times minus 4. And we've got minus 2 times minus 4 is positive 8, and we've got an x over there. Right, moving on to question 2. We've got a binomial times a binomial. In other words, 2 terms in the first bracket, 2 terms in the second bracket. We need to multiply every term in the first bracket by every term in the second bracket. So let's start with 3x times 3x gives us 9x squared. Then next up we've got 3x times 4y, which gives us positive 12xy. Then we've got minus 4y times 3x gives us minus 12xy. And finally, minus 4y times positive 4y gives you minus 16y squared. These two terms in the middle are like terms, so we can add them. So 12xy minus 12xy actually just gives us 0. So our final answer is 9x squared minus, don't do that, minus 16y squared. I've written that terribly, so let's rub that out and write it a little bit nicer. Minus 16y squared. And you may pick up that that's a difference of 2 squares, so you can go straight to that if you can. Question 4 is very similar to question 2. We've got a binomial times a binomial, so multiply every term in the first bracket by every term in the second bracket. So 2x times x is 2x squared. 2x times 5 is 10x. Minus 2 times x is minus 2x. And minus 2 times positive 5 is minus 10. These two terms in the middle are like terms, so we need to add them. So if we do plus 10x minus 2x gives us plus 8x. Next up, we got question 5, and if we're squaring something, it means you multiply it by itself. So let's rewrite this as 4 plus 1 over x times 4 plus 1 over x. So we can see what we're doing. Now it looks like question 2 and question 4. Multiply every term in the first bracket by every term in the second bracket. So 4 times 4 is 16. Not too bad so far. 4 times 1 over x. Let's just do a little bit of working out on the side here. And we've got 4 times 1 over x. Well, 4 is the same as 4 over 1. So if we do write that as 4 over 1, now we've got a fraction times a fraction. And that's easy because we multiply numerator times numerator. 4 times 1 is 4. And 1 times x is x. So we've got plus 4 over x. Now it's going to be very similar when we multiply 1 over x by 4. We've got 1 over x times by 4. And let's write 4 is 4 over 1. So we've got 1 times 4 is 4. X times 1 is x. So plus 4 over x. And finally, 1 over x times 1 over x. Well, same strategy. 1 over x times 1 over x, multiply numerators, multiply denominators, plus 1 over x squared. Now, these middle terms, again, are like terms. Middle terms, I mean 4 over x and 4 over x. So we've got the same denominator, so we can just add our numerators together and say, quite simply, we've got 8 over x. Moving on to question 6, we just need to distribute our minus 5x times by each one of these. The first bit's not too bad. Minus 5x times 1 is just minus 5x, but perhaps it's the second bit that's tripped people up, and I'm going to do it in a bit of working on the bottom here and say minus 5x times 5 over x. And if you've watched question 5 before this, you'll probably know the strategy, which is just write each of them as a fraction. Now we can multiply numerator times numerator gives you minus 25x. denominator times denominator 1 times x is x, and we can now cancel. Now x goes into those ones, so we're left with minus 25. Yes, at this stage you could have gone minus 5x over 1 times 5 over x, cancel these x's straight up here, and gone straight to minus 25. For question 7, the best way to do this is to factorize your numerator and factorize your denominator. Do not be tempted to just cancel those two x squareds. So we've got in our numerator, what's our highest common factor? It's x squared, and x squared times what gives us x cubed? Well, times x. X squared times what gives us 2x squared, plus 2, our denominator is still x squared. Now we can quite merrily cancel these x squareds, and we're left just with x plus 2. Question 8, and clearly we need to keep on practicing our factorization. 3 different options for factorization. Highest common factor, always the first thing you check. Then, is it difference of 2 squares, or is it a trinomial? Trinomial has 3 terms, like a tricycle has 3 wheels. So, highest common factor for question 8. Highest common factor is 1. Not too interesting. Definitely not difference of 2 squareds. Definitely is a trinomial because there are 3 terms over there. X squared, minus 4x, and minus 21. So let's factorize it into 2 brackets. The first term in each bracket, when you multiply it together, is going to give you x squared. Well, x times x gives you x squared. The second term in each bracket, when you multiply it together, is going to give you minus 21. Now, there are going to be a few options here. I'm going to jump straight to the correct answer. And that is, well, 7 times 3 gives you 21. Now, we need it to equal minus 21. So it's either going to be minus 7 times by positive 3, because that gives you 21. And for our middle term, minus 4x. Just focus on the minus 4 in front of the x. Does minus 7 plus positive 3, does that equal minus 4 is our question. If it does, then we're in for a winner. Well, minus 7 plus 3 is indeed minus 4. So, minus 7 plus 3. So, to run through it again quickly, minus 7 times positive 3 gives you minus 21. Minus 7 plus 3 gives you minus 4, the middle term. Right, okay, question 9. We've got factorization. So on the bottom here, we've still got 3 options. Highest common factor is 1, so not too interesting. Difference of 2 squareds. Yes, it is. X squared is a square number. 9 is a square number. So for difference of 2 squareds, we break it down into 2 brackets. First thing we look at is the x squared. What is the square root of x squared? Well, it's x, so x and x. What's the square root of 9? It's 3. So 3 in each bracket, change sign in each bracket. Plus minus. If you multiply this out, you can do it to check for yourself. It will give you x squared minus 9. Question 10. We've got factorization once again, and let's run through it. Highest common factor, dots, trinomial. Highest common factor. Yes, there is a highest common factor. We can take a minus 9x out of here, and we're left with what? Minus 9x times what gives you minus 9x squared? Well, we just need to multiply it by x. Minus 9x times what gives you minus 27x? Well, just times plus 3. You could check by distributive law that minus 9x times x gives you minus 9x squared. Minus 9x times positive 3 gives you minus 27. Some of you might ask, what happens if you took positive 9x out? That would be fine. In your brackets, you'd have minus x minus 3. Generally, however, you take out the negative, so you're left with a positive x in the bracket. Either way is going to get you the marks. Either way is correct, because we don't know what we're using this for at the moment. Okay, question 11, and what surprises me is that very few people ask for question 8, but lots of people have asked for question 11. We're doing the same thing here. We need to factorize, and let's run through our things that are on the bottom right. Highest common factor, it's 1. Not too interesting. It's not difference of 2 squareds, it's a trinomial, 3 terms, like a tricycle. So, let's go down. Bracket, wrong type of thing. Let's go bracket, bracket, that's a terrible bracket, bracket, bracket. What times what gives you x squared? Well, x times x. What times what gives you 16? Well, I'm going to go straight to the right answer. I know that it's 4. Either it has to be negative 4 times negative 4, because that gives you positive 16, or positive 4 times positive 4, which gives you 16. So let's say we choose minus 4 in each bracket. Then minus 4 times minus 4 gives you the positive 16 at the end. Great stuff. What's minus 4? And we add minus 4 to it. Let's simplify this. Minus 4 minus 4. Well, this gives you minus 8. In other words, if you add the two minus 4s, you get minus 8, which is our middle term. So minus 4 minus 4. You can write this as they do in the memo, and it is nicer to write it this way rather than writing it as x minus 4, x minus 4. You can write it as x minus 4 squared, because that's just a much more compact way of writing it. Factorization continues with question 12. And let's go through. Highest common factor. Nope, nothing too interesting there. 1 is our highest common factor, I guess. Difference of 2 squareds. Oh, yes, look at these nice square numbers. 36, x squared, 64. These are all lovely square numbers. So difference of 2 squares looks very similar to question 9. Bracket, bracket. And our first term, when multiplied together, is going to give us 36x squared. So what times what gives you 36? 6. What times what gives you x squared? X. Okay, for our second term, let's look at our fraction, 1 over 64. Well, the numerator times the numerator is going to give you 1. Well, 1 times 1 gives you 1, so 1. What times what gives you 64? With a bit of luck, we know that 8 times 8 gives us 64, and then we just go plus and minus. Okay, I'm going to run through question 13 quite quickly because it's a bit of a silly question, really. Highest common factor is 1, so not too interesting. Difference of 2 squareds, it's not difference of 2 squareds because it's not a difference, it's an addition. So it's not difference of 2 squareds. Trinomial, no, trinomial is 3 terms, like a tricycle has 3 wheels. This is a binomial, like a bicycle with 2 terms. So we can't factorize. In other words, it stays as x plus 1. So yeah, silly question, really. Question 14. Okay, highest common factor is 1, not difference of 2 squareds. Yes, we're looking at our good old friend, the trinomial, which we factorize into a binomial times a binomial. X times x gives you x squared. Factors of 42, such that when you multiply them, you get 42, and when you add them, you get minus 1, because this is minus 1x. So we've got 6 and 7 sounds reasonable. 6 times 7 gives you 42. And if we go plus 6 times minus 7, we get minus 42. And if we go plus 6 plus minus 7, we get minus 1, our middle term. So there we are. If you jump straight to this question, go back to question 11 and question 8, which have a more detailed explanation of factorizing trinomials. Okay, question 15, which had the most requests out of all of the questions, and I can understand why. The exponents suddenly changed the game a little bit. We're still looking at highest common factor, difference of 2 squareds, or trinomial. Let's rule out difference of 2 squareds because it's an addition, not a difference, plus not a minus. And it's not a trinomial because they're 2 terms, so we must be dealing with highest common factor. Now this will probably give the game away somewhat, but let's use our exponent laws. Let's use the one that says a to the m times a to the n equals a to the m plus n. In other words, if you're multiplying with the same base, then you add exponents. But let's do this from right to left. We've got a to the x plus 1. So instead of m plus n over here, we've got x plus 1. And therefore, instead of m and n over here, we've got x and 1. So in other words, instead of a to the x plus 1, we can rewrite this as a to the x times a to the power of 1. The dot in the middle just means times. And a to the 1 is the same as a, but let's leave it as a to the 1 plus a to the x. These two are equal to each other. Now, staring us in the face, what's our highest common factor? Well, we can take an a to the x out. And what do we multiply a to the x by to get a to the x times a to the 1? Well, a to the power of 1. Or a, same thing. What do we multiply a to the x by to get a to the x? Well, just 1. Easy when you know how? Hopefully when you practice this and the next time and the next time and the next time, you'll get them. The exponent ones are a bit more tricky than straight up algebra from the previous questions. Right, question 21. And for these questions, we're solving by inspection. So the implication is that we shouldn't have to do a lot of working out, but if you do a bit of working out along the way, that's perfectly fine too. So in this one, we asked 9 is equal to the square root of x plus 3. Now, 9 is equal to the square root of what? So let's just look at this whole thing under the brackets. 9 is equal to the square root of 81. Right? Square root of 81 is 9. 9 squared is 81. In other words, everything underneath this bracket must equal 81. So what plus 3 gives you 81? Well, 78 plus 3 gives you 81. Okay, quite a few takers for question 22. And we've got x times x plus 3 equals 0. Well, 0 times anything equals 0, right? So in other words, either this bit is 0, or this bit here is equal to 0. In other words, either x is 0, or x plus 3 is 0. Because if either one of those is 0, then that whole thing is going to be 0, because 0 times anything is 0. So from these two, we've got x equals 0, or x equals minus 3. Okay, question 24. And I said for one of the previous questions that we're solving by inspection. So the implication is we shouldn't have to do too much working out, but let's do a little bit of working out and say x squared minus 9 equals 16. Well, what happens if we added 9 to each side of our equation? We'd have x squared equals 25. So what squared gives you 25? Well, the obvious solution is 5 squared equals 25. But, and think back to the test, there was that x squared equals 49 and it was out of 2 marks. What else, when you square it, gives you 25? Minus 5. So we know that x equals minus 5 or x equals 5, because minus 5 squared is 25, 25 minus 9 is 16, same for 5. 2 solutions, you need to give both. Question 26, and our final one for this video. I've given a fairly longish equation here, and question 26 in the skills paper is always going to be one of these types of questions, but it's useful to know how to solve it if you don't know that it's question 26 in the skills paper. Let's multiply out. In other words, I'm going to distribute this minus 5 into the bracket. So our equation now is 5x from this 5x that we've got. Minus 5 times x gives us minus 5x. And minus 5 times positive 5 gives you minus 25. Still equals minus 27. Well, minus 5 or 5x and minus 5x, they're like terms. So 5x minus 5x is 0. So we've got minus 25 equals minus 27. Rubbish, I hope to hear you say, because minus 25 doesn't equal minus 27. So it doesn't matter what value of x you put in here, because x doesn't even feature in the equation. So if you put x equals 1, the equation isn't going to work. If you put x equals 2, the equation isn't going to work. So in other words, there's no value that's going to make this work. No solution. Now, hang on for a second example that's different to this one. But we need it... Yeah, go away. Anyway, so we do need to know how to solve something else that's perhaps a little bit different. So let's get rid of that. There we go. New question. And our new question says that 5x minus 5 times x plus 5 equals minus 25. New question, remember? Let's distribute this. So 5x minus 5x minus 25 equals minus 25. Great stuff, you say. 5x gives you 0. So minus 25 equals minus 25. So it doesn't really matter what x we put in this case. Because if we put x equals 1, and I'll leave this for you to check if you want, then you got 5 times 1 is 5, minus 5 times, what do we got? 6 is minus 30, gives you minus 25. If you put x equals 2, the equation works. If you put x equals 3, the equation works. In other words, it doesn't matter what x is, it's always going to work. So you can say, well, this here is true for all x. Doesn't matter what you've got. So they're two slightly different equations, and they will come up in the skills exam here, so you'll know it's question 26, but for when you're not given it and suddenly you get an equation, well, in the first case, it never worked, so there was no solution. But in the second case that we've come up with, it always works. So it's true for all x. So never mind all of this stuff, because for the equation that you were given, it was no solution. Thank you and good night.